A door, a window switch, or a sensor in the car demands complex, organized structure in a manufacturing company to assemble. If we were to place ourselves in that factory setting, one could see the engineer's blueprints for executing the project. The project manager, who receives the Cliff Notes translation to direct his workers to connect and assemble piece by piece required to make the door, the switch, or the engine. Ultimately, it's the sequence of events happening in the manufacturing company as we speak that fabricates the end product, the car. Switching gears to another manufacturer, the eukaryotic cell is responsible for synthesizing or making proteins that form vital organs when placed together in the correct order. Now, pressing the brakes, we must zoom in into the nucleus where protein synthesis begins. It is in the nucleus of a eukaryotic cell that one finds the genetic information, or as I like to call the manuscript of life, the engineer's blueprints. The genetic information is DNA, a dual helix composition of complex instructions which must be rewritten into mRNA and then get translated or moved to the ribosome, the rRNA found in the cytoplasm. mRNA would be the transcribed step-by-step instructions to synthesize not the entire organism, but the individual proteins that, when properly assembled, make the tissue that makes the organs and ultimately makes the organism. Now, who's responsible for orchestrating the assembly of proteins? The rRNA, just like a manager, is keen to place his or her workers in their respective assembly line location. The ribosome, the rRNA, assorts the tRNAs with their respective amino acids or their parts for the purpose of synthesizing the desired protein. The rRNA cannot talk like a factory manager, but communicates what it wants in codons, a three-letter word language which the assembly workers understand. tRNA is like the assembly workers who solder, or you could think of it like peptide bonding, the fabricated components together, the amino acids. To make the desired protein, like your heart, the engine, the PCM, like your brain, or the lighter sensors, like your eyes. The rRNA is who commands this to be done using the instructions from DNA broken down like what I like to call the Cliff Notes translation. The protein is the end product, a masterpiece of well-directed steps that we have yet to still fully understand today. The protein is again the specific arrangement of amino acids who are assembled by the tRNA, managed by the rRNA, instructed through the mRNA, and coded by the DNA. The arrangements of proteins, well, that in plain terms forms the tissue that makes the organs, which gives life to the organism. To summarize, protein synthesis is the manufacturing of proteins in a cell. The location is within the cell, inside the nucleus, the cytoplasm, and the ribosomes. The steps to carry out protein synthesis begin with DNA, the engineer's blueprints, which must be transcribed into mRNA, which are a simplified message. The mRNA must then translate or move out of the nucleus into the cytoplasm where the rRNA or the ribosomes are found. The rRNA, the manager, interprets that message delivered by the mRNA, which are your Cliff's Notes, and then chunks them into a codon language, which is understood by the tRNA, the assembly line text. The tRNA, the text, then report to the rRNA, the manager, and follow the sequence in place by the mRNA, the Cliff's Notes in order to arrange the specific amino acids that make the part. So finally, the protein or the desired part of the car is assembled by the cohesion of amino acids. Individual components to the part through peptide bonds are like your soldering, your riveting, and your gluing. And this gives way to the big picture, the car or the organism. So I just wanted to say, I don't take the credit for any of this. I am only the person that interprets all this beautiful information and detailed construction of life. All the credit, as you well know, goes to the engineer of life. Thank you.